Hello and welcome to today's lesson on internal energy, which forms part of the particle model of matter topic in GCSE Combined Science physics. So in today's lesson we're going to try to understand what internal energy is. So we should hopefully be able to define what internal energy is, understand how internal energy is calculated, and link the internal energy of a substance to different situations, which forms part of the AQA Combined Science specification 4.3.2.1 internal energy. So in the particle model, we should consider all forms of energy stored in the particle structure. And in the particles of a substance, there are two forms of energy stored present. This is the case if it's atoms or molecules or ions. Any type of particle will have these two forms of energy store. The first energy store is the potential energy store, and this is due to the intermolecular forces of attraction between particles. The second type of energy store is the kinetic energy store, and this is due to the particles either moving or vibrating in the particle model. Now together we can combine these two energy stores to say we've got the total energy of the particles in the substance, and we call this the internal energy of a substance. So the internal energy is equal to the kinetic energy plus the potential energy, but it's important to note that it's for all of the particles. So to summarize, the particles within a system have a kinetic energy store, and this is due to the fact that they are moving. The particles are also a potential energy store due to the fact that there is intermolecular forces of attraction between the different particles. The sum of all these kinetic and potential energy stores represents the body's internal energy. So internal energy is equal to the kinetic energy store plus the potential energy store. So we can summarize this idea as the following. We can say that from the particle model of matter, all substances are made out of particles, and the energy that these particles have in total is called the internal energy of the substance. Now the part of the internal energy is the kinetic energy of the particles, which is how much the particles move or vibrate, whilst this can be changed by changing the temperature of a substance. Increasing the temperature of a substance increases the kinetic energy store of the object. So therefore it increases the internal energy of that particular system. Now this is achieved by adding work into it, by placing work into the system, and the most common way to achieve this is by heating up the object. Now the other type of energy store in the internal energy structure of the part of the substance is the potential energy of the particles. This is how much the particles are attracted to each other. The potential energy can be changed by changing the state of the object. So it can be increased by going from a gas to a liquid to a solid. So the internal energy can be changed by changing the state of the matter from the gas to a liquid to a solid, which again is achieved by heating up a system, which is achieved by doing work. Now therefore the internal energy is equal to the kinetic energy plus the potential energy, but it has to be considered for all of the particles of the object. Now it's important to note that the formal definition of internal energy is the total kinetic energy and potential energy of all the particles that make up a system. So increase in either the potential energy or the kinetic energy store will result in an increase in internal energy, and the increase in the internal energy of the object can take place by heating. Now it's important to note that changing the conditions of the object will not change the conditions of the particles, so will not change the internal energy, because these stores are internal to the system. They're not combined to the external stores you've covered previously. So if you want to change the internal energy of an object, you must alter the particles of an object. So therefore, if we want to change the kinetic energy store, we have to change the temperature. So this will also change the internal energy store. So changing the temperature of substances changes the kinetic energy store and therefore the internal energy store. Now in addition, changing the potential energy store changes the internal energy store, and that occurs when the state is changed. So changing the state of matter of the object will change the potential energy and therefore the internal energy of the substance. Now you may only change one energy store of the internal energy at a time. When you're changing the kinetic energy store, you are not changing the potential energy store. And when you're changing the potential energy store, you can't change the kinetic energy store. So what that means is when an object changes state, it does not change temperature. And when an object changes temperature, it does not change state. So this means an object can either change state or it can change temperature at a particular moment, because the change in energy can either go into the kinetic energy or it can go into the potential energy of the internal energy. It can't go into both at the same time. Now, what have we learned in today's lesson? That the energy stored inside a system by the particles that make up the system is called the internal energy. The internal energy is the total kinetic energy and potential energy of all of the particles that make up a system. Heating changes the energy stored within the system by increasing the energy of the particles that make up the system, and this will either raise the temperature of the system or produce a change of state. So if we've been successful and we've learned in today's lesson, we should be able to define what internal energy is, understand how internal energy is calculated, and link the internal energy of a substance to different situations. I hope you've enjoyed today's lesson on the internal energy, which is part of the particle model of matter topic in GCSE Combined Science, and have a lovely day.